So we talked about what a probability distribution is. In this part of the course, we're going to be looking at 4 different probability distributions: the binomial, the geometric, the hypergeometric, and the Poisson distribution, because they all model different sorts of real-world situations. If you want to know what I mean by that, think back to the probability examples we've looked at. Flipping a coin, if we want to calculate the probability of 3 heads in a row, it's 1/2 times 1/2 times 1/2. If we want to calculate the probability of drawing 3 aces out of a deck, the probability changes each time, right? Those are dependent events. So we would use a different tool for calculating the likelihood of drawing 3 aces than we would the likelihood of rolling 3 sixes or flipping 3 heads. For each of these distributions, we're going to be doing a few things that are kind of going to stay the same. We're going to have to do them a little differently for each distribution, but they're going to be the same sort of tasks. And I just want to share with you what those tasks are. I call them the things that we're going to do for each of these distributions. And there's 5 of them. 2 are really closely related and the other 3 are really closely related. The first thing is we want to be able to calculate the probability of a specific outcome. So in this distribution or this situation, let's say we're flipping 10 coins and we're concerned with how many heads we flip in those 10 flips. So our outcomes are going to be anywhere from 0 heads all the way up to 10 heads. And we want to be able to calculate the probability of each one of those things. So for example, the probability of getting exactly 3 heads is 0.117, which means that should happen about 11.7% of the time. We should get exactly 3 heads. Not terribly rare, but not terribly likely either. Another thing we want to be able to do to determine if we're outside of the range of sort of normal, we want to be able to find out if something is a really unusual event. We want to be able to calculate the probability of a range of outcomes. We call this a cumulative probability. I want to find the probability that we roll or we flip no more than 3 heads. So that's the probability of flipping 0 plus the probability of flipping 1 plus the probability of 2 plus the probability of 3. We could calculate those all separately and add them up, but we're using the calculator. We're going to be able to just calculate that all at once. And turns out that for that example, it is 17.2% of the time. So flipping 3 or fewer heads is not really terribly unlikely to happen. It happens almost 20% of the time. Another thing we want to be able to figure out is the mean, which is sort of the most expected outcome or the center of the distribution, right? Means a measure of center. So in a sense, we want to think of it as kind of the middle. And in this distribution, it will be exactly the middle, right? You already know that. You flip a coin 10 times, the most expected outcome, the most likely outcome of all of the possibilities is going to be 5. So our mu here, right, mean, lowercase mu, would be equal to 5. And we'll talk about how to calculate that for the different distributions when it comes time to do that. This one's really very easy. The probability of head is 1/2. 1/2 times the number of flips is 5. No problem. The standard deviation. How spread out is this distribution going to be? Is it going to be all clustered in 4s, 5s, and 6s, or is it going to be more spread out, 3, 4, 5, 6, 7, 8, that kind of thing? For this particular distribution, our standard deviation is 1.58. Where that comes from, we will learn formulas for that, again, when we talk about the specific different distributions. And the reason we care about the mean and the standard deviation, if you think back to some of the stuff we did at the end of the first part of the course with z-scores and percentiles, we want to be able to use the mean and the standard deviation to figure out if particular outcomes are likely or unlikely. If somebody tells us the nature of a situation, then they say, hey, I just flipped these 10 coins and it's a binomial distribution and I got only 2 heads. Is that extraordinary or was that to be expected? We want to be able to evaluate how remarkable a particular outcome is. And the real short, easy way to do that without having to calculate too many probabilities is to look at our range of likely outcomes, ROLO. And remember, we did that before. It's very easy to calculate. All we have to do is double the standard deviation. You double that, you get a little bit more than 3. And then subtract that from the mean. So 5 minus 3 is 1 point something, round that up to 2. You can do that in your calculator. Double that, subtract it from 5, you'll get 1 point something, round that up to 2, and then double that, add it to 5, and you get 8 point something, round that down to 8. You always want to round inward when you're talking about the range of likely outcomes. So we get 1 point something to 8 point something, round that in to 2 to 8. Okay, so range of likely outcomes is from 2 to 8. That means that 95% of the time, on average, if you flip a coin 10 times, you will get between 2 heads and 8 heads. 95% of the time, 2.5% of the time, you'll be lower than that. You'll get 0 or 1 head. And 1.5% of the time, 2.5% of the time, you'll get more than 8, which would be 9 or 10. Okay, so those are the things. Probability of a specific outcome, probability of a range of outcomes, which we call cumulative, and then find the mean, the standard deviation, and the range of likely outcomes. And we'll be doing that for each of 4 different probability distributions next time.